Welcome. In this short video, we'll see how Hadoop as a big data platform can be used to optimize your data warehouse infrastructure and how Pentaho works in combination with Hadoop to deliver a complete big data solution. We'll start off by taking a look at a typical data warehouse. Then we'll see how easy it is to offload data using Hadoop along with Pentaho's data integration, and to do so with zero programming. Then we'll see a quick 3-minute demo showing how the actual data is ingested, enriched, aggregated, and analyzed using simple drag and drop processing. Let's look at a typical data warehouse architecture for a company capturing huge amounts of call detail records, or CDR data, represented by the blue data source on the left. This data warehouse is at capacity with only 2 years of CDR data, and nightly ETL workloads are complex, resource-intensive processes that run most of the night. The company needs to analyze a full 10 years of calling data, yet most of the historical data resides on a tape archive. The company continues to grow while this data warehouse architecture is not meeting their needs, and scaling it is too cost prohibitive. Data warehouse optimization with Hadoop allows the company to ingest CDR data into Hadoop along with other data. This frees data warehouse capacity for high-value transactional data, while also lowering costs and meeting compliance requirements. And since the data is rescued from tape, it is available for reporting and analysis. Pentaho plays a strategic data integration and analytics role for migrating to Hadoop. Within data integration, you have ingestion of structured and unstructured data into Hadoop and processing with visual MapReduce and orchestration capabilities to merge Hadoop with existing data sources and utilities. Within analytics, Pentaho enables self-service analysis and reporting on Hadoop data. Pentaho Visual MapReduce eliminates the need for Java programming. Suppose your requirements call for these 8 processes to transform and enrich your data. In this example, Pentaho's drag and drop ETL design environment is used to visually create a transformation that is run as a native MapReduce application distributed across the Hadoop cluster. In this short demo, you'll see how to use Pentaho to ingest CDR data into Hadoop, execute MapReduce to enrich the CDR data, create and load a Hive table with the MapReduce results, and perform analysis on 10 years of data. I have now opened Pentaho Data Integration, or PDI for short. PDI is a drag and drop ETL design environment for big data. In this example, we are connected to the Hadoop cluster. The first open tab is an orchestration job which performs a sequence of steps including, first, ingestion of CDR data into HDFS, second, visual MapReduce, and finally, orchestration of Hive table creation. We start with the Hadoop copy files step available in the design palette on the left. I simply open the step, connect to HDFS, and tell it my data source and destination directories. Next is the Pentaho MapReduce step. I specify our mapper, combiner, and reducer transformations. You can see the mapper transformation, call volume analysis. Let's take a look at the transformation, which I have opened in the second tab. In this transformation, we drag and drop in Pentaho Visual MapReduce to create a series of steps which transform, enrich, and filter the incoming CDR data. For example, this string cut step will separate the area code from the phone number for linking to geo-reference data in HDFS. This gives me the power to plot the CDR data in Google Maps without any Java programming required. Once the MapReduce completes, we are ready to analyze our data by clicking the InstaView perspective in the top right. Once in InstaView, I'm presented with a series of measures and dimensions to start my analysis. I'm interested to see call volume by year. I'll drag and drop to create this view of my data. We can now see the total number of phone calls for the past 10 years. I would like to create a trend chart. This chart reveals a big dip in call volume in 2008. What about annual growth rates? Let's calculate an annual growth percentage. I create a user-defined measure and give it the name of annual growth. I will now apply a conditional format on my annual growth rate. Notice 2010 had the highest growth rate. Let's filter on that year. How about plotting this data geographically? I'll add state to the view and choose a geochart map. Notice the size of the bubble is based on call volume and its color is based on annual growth percentage. I'd like to focus just on the Eastern time zone. To do that, I select time zone and select Eastern. I'll filter on Georgia and add area code to the analysis. In this example, I've been able to leverage Hadoop and Pentaho to determine annual growth trends and drill into the states and area codes driving that growth for 2010. In this short video, you've seen how Pentaho and Apache Hadoop together make it easy to move data from expensive data warehouses into Hadoop, ingesting, enriching, aggregating, and analyzing the data in an easy-to-use graphical interface. Pentaho and Hadoop together deliver a complete big data analytics solution. Thanks for watching, and for more information, please contact us at pentaho.com.